So we have a faucet right here and a typical balde or water container. So this is how the automatic water switch housing looks like right here. So as you can see here, there are three holes. The holes allow the string to get through. Alright, now let's say we're going to pull this string right here. So the force is going downward here. Now, as this string is pulled right here, this string is also going to this direction. Alright, now that string is going to that direction, so it's like it's pulled. So this section right here where the string is having contact with the knob, since it is going in this direction, the knob will turn in this direction as well. So it's a clockwise direction going along with the string or the direction of the pull. Now that the knob is twisting like this, it means that this string right here will also be going in this direction. So this leaves us to the last part, which is here. So since it's going in this direction, it will pull this string upwards. So they have a one direction of movement. So let's try pulling here. So if we pull this string right here, so this means that this string will also go to that direction. So since the motion is going there, this knob will also follow that direction. So since it's pulling there, it's going here, so the turn will be like this. So it's a counterclockwise direction. So if we pull here, that is pulled, and this is also twisted to that direction. So this leaves the following string to follow that, and right here it's going up. So as you can see here, it's still following a one-line direction. So as force is applied here, you can see the knob of the faucet turning. So as the knob turns, it allows modulation of the water flow, and in this scenario, the faucet is slowly closing. So here, if we pull here, and the knob turns here, as you can see in the previous video, it slows down. So it means if we pull this weight, this string right here, it will tighten the faucet and slow the water until it closes. Now, if we pull the other string and the knob goes in that direction, it will loosen instead and allow water to get in the container. Now that we know the working mechanisms up here, now let's go down under. There are two strings, but only one can be pulled at a time. Let's find out how and why. It's the principle of buoyancy. Buoyancy is the ability of an object to float on water or air. Whether or not an object has buoyancy, it depends mostly on two factors: the amount of water an object displaces and the density of an object. The principle of buoyancy is expressed here in this formula and its corresponding entities.
So these are the two materials that are tied to the end of the two strings. One that is less dense and displaces more water, and the other one that is more dense and displaces less water. Now let's analyze the forces present on those materials.
So there is this force that pulls the string downward, and this force is caused by the weight of this ball, which is its mass times the acceleration due to gravity. Now, there is also an opposite upward force, which is caused by the fluid below it, and that is our buoyant force. Our buoyant force, the density of this fluid right here, times the acceleration due to gravity, And also this space here, and when the ball is submerged right there, it pushes downward and displaces this space. And this space is the volume of the displaced fluid right here. As you can see here, the ball is floating. This means that its buoyant force is greater than its weight. So as the string is pulled by the weight of the ball, the buoyancy acts to negate or counter that movement, therefore holding the ball in place. So it is in equilibrium. Since the buoyant force will counter the weight, which means it supports the ball, at the same time it prevents it from falling, therefore the position of the ball is dependent on the water level. That makes that the pool is also dependent on the water level. When the water level is high, the length of the string between the ball and the faucet is short. But as the water level gets lower, the ball will need to follow the water level in order to reach equilibrium, and that would lengthen the length of the string. So as you can see here, the water level or the height is inversely dependent to the length of the string. So if we have a high water level, the strings is basically shorter, and if we have a low water level, we have a high string length. As the water level changes, it affects the length here, and as that length changes, it also affects how the knob turns. Since when you pull here in this direction, when the water level drops, the knob displaces from B to C, and therefore it makes a counterclockwise direction, thus opening the water valve. When the water level rises, the ball moves with the water going upward, and therefore the pulling motion is now being led by the counterweight, where our counterweight is a negatively buoyant object which does not float. The counterweight enables the knob to move in this direction and slowly closes the valve.
Sounds correct. Sounds